So we now get on to the interesting case where we're defining non-empty lists. So here our class is called sebcons T. It's a non-empty list whose elements are all of type T. Again, it extends our abstract class seblister T. Now, non-empty lists have two components: a head of type T and a tail of type seblister T. So those are the two components of our non-empty lists. Notice that empty lists didn't have any components, any fields at all. So when we have components, we always need a constructor. A constructor has the same name as the class. So sebcons is our constructor, and it takes two parameters. The first one is of type T, the same as this, corresponding to this first field, and the second one is of type seblist T, corresponding to the second field. And all like we normally do with constructors, we simply update the fields with the parameters. So in other words, H becomes O1, that's the first one, and T becomes M1, so that's the second one. So it's a way of constructing a list whose head is the first parameter and whose tail is the second parameter. Well, again, for non-empty lists, our isNil method will return false because the non-empty list isn't empty. So that's quite straightforward. The most interesting one here is the commas between. That was the method that returns the string. It returns a string consisting of all the elements of the list separated by commas. So there are two cases to consider here. The first is if the tail is empty. So we check whether the tail is empty by calling t.isNil. Now if the tail is empty, it means the list has only got one element in it. So we don't need any commas, we just want the head on its own. So we simply return the toString method of H. So in other words, we just simply return the head. So because we don't need commas in that case. The other case is when we do need commas. So if we come to here, we know that the tail isn't empty. So we need at least one comma there. So basically we're going to return the head followed by a comma. Now we know that this tail isn't empty. So again we recursively call t.commas between. So this will be all the elements of T with commas between, provided that there's more than one element in the tail. If there isn't, then it'll just simply give us this. So this recursive method here will put commas between all the elements in the non-empty and the non-empty list. So that's quite straightforward. Later on we'll add some methods to our list. So to add methods we will add an abstract. We'll have an abstract method here. We'll instantiate it for the empty list here, and we'll instantiate it for the non-empty list here. So how do we test our class? Well, this is how to construct lists. You simply say new sebcons, then you give it a value, new sebcons and another value. So this is in effect, if this bit here, well here we're constructing the, inside here we're constructing the empty list, we're creating an instance of the empty list. Here we're constructing an instance of a list whose head is 2 and whose tail is the empty list, so that's the list with just 2 in it. And then from that we're constructing a list whose head is 1 and whose tail is the list with just 2 in it. So this is like the list 1, 2. And using this technique we can build up lists as big as we like. So if we run this program, it'll print out 1 square bracket 1 comma 2. In the next video I'll show you that happening.